Hi there. So you maybe notice that the video looks a little bit different. There's a couple reasons for this. The main one that affects you is that it more closely matches up with the guided notes that you'll always find the blank and completed copy of attached to each assignment. So that's really helpful. The other thing is that if you do want a copy of the guided notes in paper, feel free to print it out. If you don't have access to a printer at all and you'd really like to use the guided notes that are attached, please get in touch and we'll try to find a way to make that work for you. Otherwise, get yourself ready for notes, and we're going to start by talking about the mean value theorem for derivatives. So, if you remember the mean value theorem for derivatives, what that says is that if a function is continuous on an interval from a to b, and it's differentiable on the inside of that interval, that means that there exists a c in that interval such that the derivative at c is equal to the average rate of change there. So basically, if we look at this picture over here, if this is our interval a to b, this is the secant line. It just means that there's some tangent line where these are parallel. So hopefully that picture makes a little bit of sense. And all we know is on this picture, we just need to know that this in between is continuous and differentiable, and it's continuous at these 2 points at the end. Now, the way that you'll often see to use this is find the values of c that satisfy the mean value theorem, and they'll give you a function, and they'll give you an interval. So what they're saying is, all right, if this is the interval, find the point where this parallel tangent line occurs. The way I usually will do it is I'll just set it up with this formula. And so then I'm going to say, okay, well, f prime of c is equal to f of b minus f of a over b minus a. And then I'll grab the different numbers. So here, a is the beginning of the interval, b is the end of the interval, and then here's our function. Now, the derivative of the function would be bring the 2 down, multiply up here, so then we end up with 6c, since we're using c, plus 5. And then on the other side, we get f of 1 minus f of negative 1 over 1 minus negative 1. Now, this side's always going to be just a nice constant because the interval is a constant. And so what we're going to do is just plug in negative 1 and 1 to this function to plug them into the formula. So then we get 6c plus 5 is equal to 3 times 1 plus 5 times 1 minus 2 minus 3 times 1 plus 5 times negative 1. So that's minus 5 minus 2 all over 1 plus 1. And we're left with 6c plus 5, do a little bit of arithmetic, is equal to 5. And now we just want to solve for c, because that is our goal here, find the values of c. Subtract 5 on both sides, we end up with 6c equals 0, so c is equal to 0. And that's, for the most part, all you have to do. You might get asked, all right, what is the point at that? So then you'd plug it back into the original function. They might ask for the equation of the tangent line. We've done practice problems like that in the past. The other theorem that's important for derivatives that's similar that we've seen before is the intermediate value theorem, or IVT. And this is really helpful because it says that if f of x is continuous on a to b, and there is some n where capital N is in between the two y values. So for example, this. Here is our f of a and our f of b, so n is just in between them. There exists a c in between a and b where there's a point on the curve. So basically, if this is continuous, this c exists, And there might even be more than one, as we can see in this drawing. There'd be one there and there. Now, we can use IVT in a couple different ways. One thing that's nice is it can also prove that there are roots of functions. Because what we want to prove, and we saw this earlier, and I just want to review this, we want to show that there is a root. So what we want to show is that there is a value here, if we're looking at the graph over here, that's positive, and a value down here where it's negative, because your n value, when you want to find a root, that means that you want this to be the x-axis. So n for roots is equal to 0. And so you just want to find a positive and negative. You can use guess and check. You can use whatever method you like. I'm going to say, well, I see a constant here, so my negative is going to be easy. So I know that f of 0 is equal to -1. Now, I notice that my other terms are both going to be positive as long as I plug in a positive number that ends up being bigger when added together than -1. That's going to be true for most numbers. So you can pick another one. I'm going to say +1 because then that becomes 1 + 1 - 1, which is +1. So then by the intermediate value theorem, we know since it's a polynomial, it's continuous on every interval. And we can say that if a is equal to 0 and b is equal to 1, those are our a and b values here, then f of 0 is less than 0, which is less than f of 1. If you want to add the or equal, that's just fine because that's coming from the function. So therefore, you can use the 3 dots for therefore, f of c exists equal to 0 between 0 and 1. Now, this is not the most nicely written proof. I don't want to make this video a million hours long. So if you want to see a full proof of this, please go and read through at the attached PDF. If you have any questions on the intermediate value theorem or the mean value theorem for derivatives, please make an appointment or send me a comment in here or